So good afternoon, everyone. Today I'll be discussing about overview of geoinformatics. My name is Dr. Praffulit Bisht, and I teach geography at Miranda House, University of Delhi. So what I'll be dealing today will be what is geoinformatics, the components of geoinformatics, why do we use geoinformatics, advantages of geoinformatics, evolution of the subject as a multidisciplinary domain, applications of geoinformatics, and one basic activity of starting with geoinformatics. So, as we all know that the world is rapidly changing, and in this dynamic entity, geoinformatics has earned to be a special status. It started in 1970s when monitoring of environment and human activities of Earth's surface gained momentum. This was particularly the moment when environment consciousness was coming in people and satellite development was taking place. The technology played a crucial role in helping us to make environmentally appropriate decisions. Central to all the disciplines which use data recognized by their locations, geoinformatics has a central role in all those disciplines. For example, geography, for example, sociology, political science, or even the elections that are happening these days. Geoinformatics plays a great role for decision makers. And recently, the trend is for disaster management studies also. Before we delve into the deeper analytics of how we use geoinformatics, what softwares we use in geoinformatics, let us first start with the basic concept of geoinformatics. It is made up of three words: geo, meaning geography, infor means information, and matics is mathematics part of it. So essentially, it's a combination of geography, computer science, and mathematics. Geoinformatics can be defined as science and technology that deals with geoinformation, its acquisition, creation, storage, processing, presentation, and dissemination. These are various disciplines where synergy of various disciplines come together. For example, in remote sensing, photogrammetry, cartography, geographical information science, geodesy, computer science, and mathematics. I'll be dealing with them separately in great detail. In all, what you can say is creation, processing, and visualization of spatial data is geoinformatics. So what is geodesy? Geodesy is the science, particularly mathematics, of learning about Earth's shape. So you must have heard that what is the shape of Earth? Some people say it's round, some people say it's ellipsoid, but in reality, Earth is neither round nor ellipsoid. What it is, it's geoid. In geoid, all the undulations are taken care of in a mathematical model. All these learning about these mathematical models is the basis of geoinformatics, and that is where you start your GIS software from. Then some parts of cartography are also a part of geoinformatics. For example, the art and science of map making is called cartography. So basic principles of what projections are, how these projections are different from one another, what is the utility or better part of one projection, and what are the limitations. To know all these things is also basic understanding of geoinformatics. GIS is derived from geoinformatics. It's geographical information system. Some people also called it geographical information science. In this, layered structures are recorded, and these layers are then used for analyzing various aspects of the subject. Geography, of course, geoinformatics is made up of the subject geography, all the domains whereby spatial patterns are to be recognized, special units are to be looked and studied in great detail, either at regional level or at global level. Geoinformatics gives you the tools at hand. GPS, handheld devices these days, your mobile phones have it, but what is required in geographic information system or geoinformatics is the actual time that atomic clocks from the atomic satellites gives, and then it gives the precise location on the map of the world, and exact location is pointed out through using these GPS satellites. These days, India is also developing its own GPS. It's called Gagan. Then principles of photogrammetry. What are principles of photogrammetry? Actually, arithmetic calculations are used to find out about height of particular buildings or features. or height of a physical feature that can be found out from, let's say, by the shadow of that feature on particular time of the day. All these principles together come in the subject called photogrammetry. Computer science, because all these things are happening on a software. We'll be learning about various softwares. For example, QGIS, ArcGIS, all these softwares have a basic computer code running at the background, which is giving you the capability to look at those satellite data or primary data that is collected from the field. And then remote sensing, the data which is collected either in digital elevation model form or in raster forms, they can be used to analyze a particular scene, or time or change detection can also be done. What are the various components of geoinformatics? Various components of geoinformatics include computer science, geodesy, cartography, photogrammetry, remote sensing systems, global positioning systems, geographic information systems. Now, what is the advantage of using geoinformatics, or why do we use it? First is it has the ability to acquire spatial data and integrate this spatial data with non-spatial data, which is the descriptive information about spatial data. So what is a spatial data? For example, if you have a map of a place, let's say you have a map of North Campus, Delhi University, that is spatial data because it has latitudinal and longitudinal values attached to each point digitized. Then you can give some information about each polygon, line, point, so that some kind of description about each point is there, which will be used later on for analytical part. Then second is they are time and cost effective because it's not always possible to go to places very frequently. If you have satellite data of that place, you can very easily compute data and analyze what are happening and the physical and phenomena that are happening in there. It can also provide a synoptic view or multi-date information. At times when you have to go to a glacier, let's say the access points are choked by heavy snowfall. So what happens is you are limited by physical access. But if you have satellite data of that scene, what you can do is you can still have a look in the colder months, or let's say in the winter months of those areas, and those glaciers can be monitored. It helps in collecting of data without disturbing the area or pristine beauty of that area. So this is particularly possible, let's say of a Nanda Devi glacier. So that is an eco-sensitive zone, and lot of tourist activity is taking place, which is also causing the glacier to melt. If there is a way to find out about the glacier, not by not going to that glacier, is through collecting data without disturbing it. You can also answer where, when, what, and why scenarios because it gives you an analytical tool at hand. If you are given particular training, you can also predict some events, certain phenomena. You must have heard about glacial lake outburst flows. Those can also be predicted if you have a basic understanding of geoinformatics. What are other advantages? It also helps in visualizing the data that you have acquired or analysis that you have done. It also helps in planning for future and can also help save human lives. Comprehensive solutions for policymakers and decision makers can also be done. It assists in planning strategies and is also especially useful in cases where disastrous events demand quick decision making. How did geoinformatics became a multidisciplinary subject, or is it also a subject? Can we have a discussion on that? Actually, from being a tool in the early 1970s, it has now become a science in itself. So there is a remarkable shift in perception. The paradigm shift happened because a subject or a discipline should have certain elements such as textbooks, academic programs in universities, scientific conferences being organized, and related journals and academic societies. All these criteria are fulfilled by geoinformatics. All these elements exist with geoinformatics, which qualify it to be called a discipline. Therefore, geoinformatic application specialists need to have a sound knowledge of theoretical aspects and practical approaches to integrate many resources for information. What are the various applications for geoinformatics? So one being natural resource management. So with this, you can also have, let's say, analyze the forest cover or changing forest cover. One way to go about it could also be looking at urban forests. So let's say Delhi has what kind of forest area, and over the years that forest is increasing or decreasing. You can analyze this with the help of geoinformatics. It also helps in land use and urban planning. So you must have seen that certain areas are suitable for agricultural purposes, certain areas are best suited for urban planning or residential purposes. And in between, they can also be used for industrial purposes. So with if you have a remotely sensed data about those areas, or you have now drone footage also that can be used for detailed urban planning and that are being used by various agencies in India. Most importantly, they are being used for disaster related studies. For example, you must have heard about Joshimath floods or Joshimath landslides recently. Flood prone areas can also be demarcated, or you can also predict that which areas are more flood prone in an urban areas. Governance, because all these things together help in deciding a various effective and efficient governance of a city and also in rural areas. So geoinformatics gives you a tool and a science to understand this. Atmospheric modeling has been catching up very lately. It's let's say the debate about climate change and how much temperature are rising and what all impacts that temperature rise is having on the oceans or on the land surface or on the agricultural production in an area. Climatology and meteorology are very much important, practical important, because with this you get the forecast about what kind of monsoons are going to be there. Is this an El Nino season or not? Is this a La Nina season? Or if the oceans are going to become very warm, so moisture content will get impacted. So all these things are helped with the geoinformatics and agriculture for sure, because what kind of crops can be grown, the kind of, if you have a data about what kind of rainfall is going to happen, if it's too much of rainfall, then farmers can protect themselves, or maybe they can take insurance for their crops. And health and epidemiology, so even the subject of geoinformatics started with health and epidemiology, whereby one single well was infected by various you can say vector-borne disease, and that was located because of concepts of geoinformatics. So with this, I leave you with one activity of downloading QGIS software. You directly go to qgis.org, download for Windows, or if you have MacBook, you can download it for Mac, and the download will automatically start. You please check the download folder and run the exe file. This manner, you will have your QGIS installed on your software. It's a free software, so you'll not have to pay anything. There is a contemporary of QGIS which is called ArcGIS. It's a paid software and it gives you some advantages over QGIS. But at the beginner level, I would suggest you download QGIS software. Thank you. Thank you very much.